Search at Elastic, and if you're not familiar, Elastic is the company behind Elasticsearch, one of the most widely adopted and downloaded open source search engines in the world, used for really a wide variety of search applications. I personally focus primarily on the kind of traditional search, text search in a search engine, sort of, a search box and 10 results, or at least what it has historically been there. Today we're going to talk a little bit about how those search engines fit into the overall generative AI ecosystem. So very excited to be here and take you through some of our plans. First, maybe it's good to recognize that search is rapidly evolving, and in particular, consumer expectations of search are rapidly evolving. So with the rise of tools like ChatGPT and the foundation models, people are pretty rapidly adopting those and starting to expect the other search engines that they interact with on the internet to be able to satisfy a kind of a new category of queries that are stated in natural language, that have nuance, and they want the search engines and the applications they're interacting with to really be able to interpret that nuance in that natural language and give these very prescriptive responses. And we're seeing this across all the different, a variety of different use cases that we operate in. From HR search or something like workplace search or customer support applications or even e-commerce search applications, they're all changing in this way. I mean, one thing that you might notice about some of the questions or the example queries that I have up here is that these, in order to answer these questions, the search engine or the generative AI application really needs access to proprietary data, some private data that's unique to that application that may not, and most likely was not, part of the training set of the foundation model. And so as the builders of Elasticsearch, it's very important for us to be building the capabilities and the tools that you all will need and our users will need to build these kinds of applications. And so really our goal is to be the bridge between these foundation models and the private data that is oftentimes already indexed into Elasticsearch or that our customers will index into Elasticsearch. And how are we making the right tools to help get the right content at query time over to a foundation model? And we're not in the business of building the foundation models themselves. We're really in the business of building the retrieval part of these applications. And why does retrieval matter? And first, I think we all want to provide a great user experience, answer the question that the user has asked, and that's key to pretty much any application. But also, the ability to, if you do this well, you can control costs with something like a foundation model as you process questions through it. You can ground it and eliminate or significantly reduce hallucinations by providing factual grounded data at query time as part of the query. And then, the third point there is very important to me, which is that, search engines in general, certainly the search applications that our users end up building, they're all a little bit different. They're unique to each individual company that builds it. They're unique to the data. The relevance models need to be somewhat unique. And so, we're building all of the kind of key components that we think people need to take, out of that toolkit and ultimately build these applications however they decide they need to be built. And we're trying to package all of that as one cohesive, easy-to-use thing. So this diagram shows a bit, at a very high level, how a search engine typically fits into a generative AI application. It's an approach called retrieval augmented generation, where without the retrieval portion, you would typically pose a question like the one you see here and pose it directly to a foundation model like GPT and expect an answer to come back. But if that question needs to be answered in the context of a specific company, if you're building this application for your own employees, for example, to answer the question, does the company understand or own my side hustle? There's a lot to answering a question like that. First, understanding what does side hustle actually mean, and also what are our internal company policies relevant to this. So in retrieval augmented generation, you pose that question also to something like Elasticsearch, which probably has all of your internal policies indexed. And if we're doing our job correctly, essentially line 2B here, and we give you the most relevant content that's been indexed, we can put that in the context window and then ask the large language model essentially to answer the question, but in the context that we've provided there. And they can give you a much more exact answer that's specific to your company. So that's how it works at a very high level. But what are we kind of building to make sure that that relevance model is possible so that we can give you the most relevant capabilities? And so you've all probably heard a lot about vector databases. That's something we've also been investing in at Elastic. And so that's kind of at the core. If people want to use vectors to do retrieval, you need a great vector database to be able to search over text embeddings or embeddings of any sort. And then, if you zoom out a little bit, you also need the ability to create those embeddings. Oftentimes, you can create them offline, but if you can pull that into one single system, you can eliminate a lot of the friction of building something and keeping things in sync. And then, when you zoom out even farther and you start thinking about bringing these into real-world applications where you need to be able to filter and facet and, maybe bound some of your results to a specific geographic location or something using a bounding box, these are all actually capabilities of kind of traditional search engines like Elasticsearch. So we wanted to make sure that as we added these capabilities like vector search, vector databases and, creation of embeddings or doing inference inside of the system, that they also fit nicely with all the other tools that we've been investing in for the last 10 years or so. And so this ultimately culminated in what we're calling the Elasticsearch Relevance Engine. It is really the collection of all these capabilities that we think people are going to want to need here, or they're going to need for building these applications. From everything on the top, from text search and vector search to hybrid search capabilities, which is kind of the combination of the two, to actually bringing in machine learning models to perform inference inside of your Elasticsearch cluster or deployment. And then also making sure that's all packaged in an enterprise-ready, capable system, which is things like enforcing document-level security and making sure that your compliance posture can be respected. Because I think we're all thinking about that. We heard a little bit about that in the previous talk. That's something that's top of mind for many companies that are trying to take these Gen AI applications and put them in production. And so all of that, those are kind of the three areas of major investment. We'll jump into two that I think are pretty unique to Elastic here in the choice of machine learning models. So, models in doing inference on those models is a big part of many of these applications, whether it's to create the embeddings that ultimately go in your vector database or for doing other aspects of machine learning inside the system. We took a very open approach to doing this. So when we thought about how we would do this at Elastic, we're an open source software company. We recognize that there's an enormous explosion of very capable models coming out every week. And so places like Hugging Face have become the de facto place where you can go seek out the newest models. And we wanted to make sure you could take a model from there, load it into Elasticsearch, and use it natively. So you aren't stuck with just something that we think is the best. As I said earlier, every relevance engine and search engine is going to be a little bit different, so you should have the option. So we worked hard to make sure that you could bring those into Elasticsearch. We also do have a proprietary model that we built ourselves. And we expect that other companies will have their own proprietary models. So as companies get more sophisticated and data science teams are building some of these models, they'll want to be able to deploy them for their own applications. And in many cases, those can be the best performing models, something like this. So all of those three options are kind of at your disposal. And we'll talk a little bit more about the proprietary model that we built here at Elastic that I'm really excited about. It's basically, it's a learned sparse encoder. It's a late interaction model, so it's meant to be essentially zero shot. You don't have to, it doesn't have to be trained on your own training data. And as you can imagine, if we're going to ship something with Elasticsearch, it's very important that it's going to work on pretty much any text you throw at it. But ultimately, the goal here is to make it so that, the goal of many of these applications, especially in terms of relevance, is to build a semantic search engine where it's not just keyword matching any longer, but it's understanding meaning. And so something like these late interaction models like ELSA or the Elastic Learn Sparse Encoder, that's really been the goal with that. And so that's a model that actually ships with Elasticsearch. So you can do all of this work without actually having to really do much on your end. You can re-index your content, pass it through ELSA. And what we're showing on the screen here, it's a bit of an eye chart, but you can see this is performance on some of the benchmarking text data sets out there, and it's performing really quite nicely. I think it's one of the top performing models right now. Who knows what the situation will be next week or the week after that. This is moving very quickly, but we're really happy with where things are today. Very briefly, what are our customers building with these things? A couple of customers, we see a lot of use cases in customer support. I think we heard a little bit about that earlier today as well as a legal e-discovery, which is something that was kind of exciting to see as well, and is really kind of illustrating some of the power of these applications. And then finally, what are we working on next? A lot of this is just going deeper into the things that we've already talked about, or that I've already talked about here, but making sure that we're continuing to integrate with this kind of rapidly evolving and exploding ecosystem, making sure that the third-party integrations that you might want to reach for as you're building your applications are seamlessly integrated with Elasticsearch. I think re-ranking is an interesting topic that we just didn't have enough time to really go through yet today. And then finally, just making the performance of the entire system even better and better. A lot of these applications today are requiring quite a lot of memory, quite a lot of CPU, so everything we can do to optimize that on your behalf is something that we prioritize. That's everything I have. I'll just pitch quickly that we have another talk tomorrow by one of our developer advocates that is going to go into this in a little bit more detail, but hopefully that was a pretty good overview, and thanks a lot for having me.